All right, so we got this problem here, and we know we're always trying to solve for our variable. I always put a line through my z's just because, you know, they look like 2's sometimes or something, so just so I don't think it's a 2 when I'm working it, I always put a line through it. Now, is z by itself? No. What's it multiplied by? 2.5, right? When we're solving, we always say the opposite of multiplying the variable by 2.5 would be to divide by 2.5. Now, you might want a calculator here, right? You could do it without a calculator if you know what the fraction for 2.5 is, but feel free to use your calculator. This would be, if you were looking at it as a fraction, if I divided it out on my calculator, I'll get the answer, right? But if I want to try to do this without a calculator, which let's try that just so we can get some math number sense out of this. This is negative 1 over, and isn't 2.5 5 halves? 4 over 2 is 2. 5 over 2 would be 2.5. But you may use your calculator here. Don't think you have to do it this way. Now, if I'm trying to remember how to do those complex fractions, if I wanted to try to do this just by hand, if you got a fraction in a fraction, it's better to have the numerator and the denominator be a fraction. That way, you know, it's a little easier to look at. So I'm going to make that negative 1 on top into negative 1 over 1, and I'm going to make the bottom into 5 halves. And if I have a fraction divided by a fraction, do y'all remember what you do?
You put the latter.
Yeah, you write the numerator down, and my numerator here would be negative 1. I'm going to go ahead and write it as negative 1 over 1 because I got fractions here, so this will be helpful anyway. And then I multiply. I change it into a multiply problem, and then I flip the bottom fraction. And again, you could have done this in the calculator without doing all this work and just divided it out, but I think this is good just for us to think about how we could have done this without it. So now I can multiply this out. I have two fractions multiplied together, so we just multiply across the top. Negative 1 times 2 is negative 2, and 1 times 5 is 5. And if you change that, they give their answer as a decimal, and I think the reason they do is because they had a decimal in the original problem. Usually, however they give you a problem is how they want you to give it back to them. Negative 2/5 would be perfect with me if you were working on a quiz or test, but if you wanted to change it into a decimal, if you think about it, decimals are easy to do. If we get how about we get a denominator of 10? That would help, right? I could multiply the 5 times 2 to get 10, so this would be the same thing as negative 4 over 10, and that would be a negative 0.4. Again, I could have avoided all this work just by saying negative 1 divided by 5.2 in my calculator. But it's kind of good to remember all these rules because they do pop back up in Algebra 2. You're going to have all kinds of weird looking things divided by each other, and you're not going to be able to just put it in your calculator because it has variables in it. Okay, we're supposed to solve for the variable. We know that, and what I like to do is always just circle the variable. You remember how you spent so much time when you were in like 5th, 6th grade, and in 7th grade I told you we don't like improper fractions, we don't like these mixed numbers so much in algebra, and I was kind of like, I don't like doing that anymore. It's because we never use them once we get in algebra as much. Is this very helpful to solve the way it's written? No. If I'm going to do algebra, 3 2/3 is hard to work with. Let's change this into an improper fraction. We really like improper fractions in algebra. They're just easier to work with. So if I'm changing 3 2/3 and into an improper fraction, do you remember that you say 3 times 3 is 9, and 9 plus 2 would be 11 over 3. Okay, so if I get it to looking like this, now there's a lot of different ways I could solve this problem. I'm going to just pick a way. I'm going to pick a way that would work no matter what's going on. So there's some easy ways to do this problem, but I'm just going to go. Do you notice here that I have a fraction is equal to a fraction, right? Does that remind y'all of anything you've done before in the past, maybe last year? We just did this today in 7th grade. They just left and they just got through doing this. You have a fraction and equal a fraction. Doesn't that look like ratios and proportions stuff? Remember that, where you can cross multiply? Whenever I see this in math, I go ahead and say, hey, this would be a good one to cross multiply on. Because if you remember cross multiplying, you can say 3 times 11 is 33. Let me write that down. That's one side of my equal sign. And then I can write down an equal in the middle. And if I cross multiply across the other diagonal, I have negative y times 3, or 3 times negative y. Now remember, negative y, the lazy math guy just didn't write his negative 1 in there because he didn't want to write the 1 down. It just hurt his itty-bitty hand too much, okay? What is 3 times negative 1? Negative 3, and then there's a y that's smushed in there, okay? So when you see a fraction equal a fraction, try to train your brain to watch out for those things. And when it sees them, try to train your brain to think, oh, I could cross multiply here, because it will come in handy later on when you get harder stuff. Okay, now I don't have y by itself. Here it is. I got a negative 3 times a y. That's what it means when it's smushed together. Yeah, what would I divide by to get y by itself? Yeah, I've got a negative 3 times a y. The opposite of multiplying y times negative 3 is dividing by negative 3, right? So what I'm going to do now is say, let's divide that negative 3 out, and if I do it to one side, I got to do it to the other side, right? Do you see the reason why we divided by the negative 3 once you write it down? Aren't you reducing a fraction here on the right side? Negative 3 over negative 3 goes into negative 3 one time, negative 3 goes into negative 3 one time, and 1 over 1 is 1y, which we just write down because we're lazy too. We write it down as a y, don't we? The reason that we do the opposite thing is so things either divide out and becomes ones, or if it's adding and subtracting, we want things to add up to 0 and go away. Now my answers, I'm almost at it, aren't I? And if I look at the other side, all I have to do is say, oh, the answer is 33 divided by negative 3. What is that?
Negative 11.
Negative 11. Y is negative 11. Okay. This one is absolute value of x divided by 5 is 2. This is a good problem to look at after the one we just did. Do you notice that as weird as it looks, I have a fraction here, don't I, on one side? Okay, I don't have to do this, but one thing that becomes really handy is to think, if I've got a fraction on one side, could I make the other side a fraction pretty easily? Yeah, I could just do what to make 2 into a fraction? Put it over 1. Now I have a fraction equal a fraction. This is what a proportion is, right? What can I do when I have a fraction equal a fraction? What did I just do in the problem? What? Yeah, cross multiply. You can solve it other ways, but it's just an easy way. It's a big idea in math, so we like to kind of learn some ways to make things look a little easier. If I could cross multiply here, then I just have to go, well, 5 times 2 is 10, right? And 1 times the absolute value of x, 1 times anything just gives you the same thing back, doesn't it? So 1 times the absolute value of x would just be the absolute value of x. I should have done that in a different color. Let me show here's the cross multiplication, and that becomes 1 times the absolute value of x. And lazy math guy doesn't write the 1 out front, does he? That's right. It's just too much work on our hands, right? Now, when you get it this way, some people, even just writing it like this helps some people just visually kind of realize what they need to do. I always like to get the x on the left-hand side because sometimes my brain will just kick in and go, oh, that's all I got to do here. If your brain hasn't kicked in here, let me ask you a question. What could you put in for x that would give you 10 when you take the absolute value of it? Absolute value, remember, is distance. And we don't talk about distance in a negative way. We always talk about it as just 10 steps this way or 10 steps that way. Yeah, there's 2 things that would work, right? The absolute value of positive 10 is 10, so one of my answers is 10. I'm going to list my answers in these fancy brackets here. But Rachel just said you could also put a negative 10 in there. The absolute value of negative 10 is 10. So we got 2 answers here, and we're not used to getting 2 answers, are we? But absolute value usually gives us 2 answers unless it's equal to 0, then we just get 0 because there's not a positive or negative 0. So that's all we need to do there. But we used the whole idea of I had a fraction on one side, let's make the other side a fraction to cross multiply. I didn't have to do that. I could have multiplied both sides by 5 and solved this algebraically. It just usually takes longer to do that. And so people really get where they like to cross multiply.